Within this PE video, I want to talk to you about the concept of centre of mass. And actually, it's one of my favourite concepts in PE because it's kind of ungraspable. It's such an odd idea. Let me define it for you first of all. Centre of mass is a point in a body, so any object, point in a body where mass is distributed evenly, in all directions. Now, when I read that or when I hear it, I have to say it doesn't mean an awful lot to me. Let me write it in first of all, evenly in all directions. Okay, so it's not the most intuitive of concepts, but let's just kind of apply it to a kind of a stick man first of all. Let me draw my stick man. Here's Fred, badly drawn head has Fred, but here he is. Fred's got two arms, two legs, and he's standing ever so proudly over there. Well, first of all, let's identify where Fred's centre of mass is. It's around about his navel point, so it's around about the belly button. And what we're saying here is that if you take a measurement of mass in any direction from that point, it would be roughly even in all directions. Now then, I want to ask you a question. Well, what would happen if my man Fred, we'll draw him in a slightly different colour this time, if my man Fred, okay, this time, he's risen one leg, and he's standing with his other leg there, and he's risen both of his arms. What happens now to Fred's centre of mass? And the answer is, well, it rises. It goes up. So if we raise our mass upwards, then the centre of mass will effectively move upwards. If we lower our mass, if we crouch, for example, our centre of mass will go down. Now, that might not seem to be particularly important, but when you start to think about it in an applied practical sense, it's actually very, very important. One of the things that you need to be aware of is that when we jump, for example, the flight path of our centre of mass is predetermined.